All right, thank you everybody for joining today. I have the great pleasure of concluding the first day of DRL jury for our Phase 2 thesis work. And as a kind of honorary lecture, kind of to extend the discussions that are really centered around design research, practice, and really trying to look at more progressive ways in which we can sort of deal with the cultural, intellectual, and technological aspects of how we approach architecture in the contemporary. We felt that it would be a great honor to actually invite Winka Dubbeldam to join us for the keynote lecture, which historically has always been given to somebody that the program has felt really epitomizes, I think, a lot of the aspects and a lot of the challenges that I think a lot of our students are kind of trying to work through, but also gives a model of how that work can go out into the world and actually be addressed in many different forms. I've had the pleasure of knowing Winka for quite some time, and I think the dialogue between the AA and UPenn, the dialogue between practitioners, this community of people that are a bit unapologetic about the role that design has in the built environment, I think is both small but also very kind of intimate and very transparent in trying to share and exchange work and discussions about how one can somehow upgrade the profession through, I think, a very kind of open and expressive way to kind of have open lines of communication. Winka, I mean, doesn't really need an introduction into a place like the AA, but for those who may not know, she's the founder and partner of Architectonics in New York City. They've been working across all scales, and I think it's a very important practice which emerged from the kind of digital design culture that was at one stage very novel into different ways of performing, from more product design and installation to some of the recent work on master planning, most notably the Asian Games for 2022, which will open in Hangzhou in China. Aside from that, and in parallel to that, Winka has always been an educator and a researcher. She's worked in many schools, but has had a long-standing relationship with the University of Pennsylvania, where she is Miller Professor and Chair of the Weitzman School of Architecture, and Director of the Advanced Research and Innovation Lab, where she's been working across a whole series of different kinds of initiatives to look at not only the material, culture, and production, but to really see architecture throughout all of its manifestations from education to practice. So the purpose also of this talk is to also highlight a publication that Winka has just launched called Strange Objects, New Solids, and Massive Things, which the AA Bookshop is selling at a discounted price today, which is a very interesting publication which tries to speak about the reemergence of the object, but with radically different sensibilities to the ones that are conventionally spoken to, concepts of seed intelligence and growth, and other kinds of aspects which I'm sure that Winka will touch on in the presentation today. So with that, it's a great pleasure and an honor to welcome Winka. It's very, I think, apt at the first kind of reemergence of a lot of the activities within the AA to kind of welcome Winka back to the AA and to have her share the latest kind of work that she's been developing with us. So with that, Winka, thank you so much for joining, and it's over to you.
Thank you so much for the kind introduction. It's a great pleasure to be with you tonight for me, lunchtime. I was also external examiner actually at the AA for, I think, almost 6 years, for a long, long time. And it was an absolute pleasure to be with you on an annual basis. And I have to say, I quite miss these little events of 3-day reviews. Absolutely fabulous school, great faculty, great students. So yeah, it's a really a great moment to be back with you. I will just start a lecture. I think that's the most important. You might know my office is in New York. I commute to Penn in Philadelphia, and I'll try and share the screen. It's always an interesting challenge. Let's try this one. And you see this full screen? Yay, first time. Good. So yeah, what you see here is an office that is trying to specialize in innovation, not in typology, so not like either commercial or residential, but really thinking about innovation in the widest sense. And I think also we look very much at the idea of, you could say, a different kind of aesthetic or different kind of beauty that really comes from deep investigations or rigorous research, and hence will give the project character and identity, but not as much maybe what we would call a standard beauty. We're more interested in the notion of the sublime, as mentioned by Edmund Burke, and his notion of terror and fear based on the sense of awe. So awe in the sense of understanding things that are striking, maybe even dangerous, or have an uncommon beauty or an uncanny kind of character. So a lot of this will be investigated or is investigated in the prototyping phase. So this is just a small overview. Most of our projects, of course, express themselves in build form, as you can see here, a glimpse of the Asian Games. But also we like to share our ideas with peers, with really any person. This is our exhibit where we were kind of testing out the ideas for the book that Theo just kindly mentioned, the idea of the strange object. And here, this exhibit is in AEDIS Berlin, is 2 years ago. And we looked at the idea of the notion of the object in a different sense. Of course, you know, books are ways that we otherwise also investigate both our own project, but also communicate this. These are the first 3 books that we published with 010 in Rotterdam, Princeton Press in New York, and DAP in Germany. And then the latest project is the Strange Object, New Solids and Massive Things. And this book, rather than a traditional monograph, is really conceived as a manual and maybe itself as a strange object. And it reflects this non-standard way our projects come into being. The book was designed by WSDA. You see on the left-hand side, Jonathan Jackson and Janet from WSDA, edited by Julia from Original Copy, Julia van den Hout, who's next to Janet. And then next to me, you see my business partner, Justin Korhammer, and some people of the office that helped work on the book. There are more people, but I always say it's, you know, the virtual world is infinite, so you'll be on the other side of the slide. And then this is the book. So WSDA really designed the book itself as a strange object in kind of a understanding of below the surface manual or taxonomy of our work, and considers each project according to its particular formal or performative characteristic, thus establishing overarching areas of research and narratives, but also reflect the singular nature of the design process and the final outcome. So there are 3 subject areas in the book, and maybe most interesting is that we are interested in the idea of protobodies or thing shapes that touch on the idea of becoming, approximating, and therefore occupying a territory between idea and space, exactly where the ego and the external world are not yet sharply differentiated or defined. This thing shape is not yet inhabited or inhibited, decipherable by habit or felt at home with, which causes the sense of uncanniness, the sensation of the almost ugly, and aimed to create or investigate an object gaining identity or character. I'm hopping a little bit into the current state of affairs, which is, of course, as we know, we are finding ourselves in the Anthropocene. with consequences I don't think I have to talk about very much, but we all know. And probably the most common denominator between all of them is that the extremity and velocity of the occurrences are both faster, differentiate sooner. It goes from cold to hot to storm to quiet and back. And of course, as we know, these issues express themselves both in garbage, in energy shortages, lack of water, drying earth, and air problems. So from the beginning, and this is really going back to when I started my office in '94, when we are already kind of aware of these issues. We talk about them now, but obviously they were already things that were occurring. And from the beginning, we were very interested in the idea of the building itself being intelligent. That actually goes also back to a robotic tower we developed for a developer at some point. But they talk about innovative skins, the idea of passive solar, energy saving systems, prefabrication and offsite manufacturing, and renewable resources. And one of the very first structures we built, which was very early on, and I'll mention very briefly, is this building with folded glass. It was the first kind of idea of parametric thinking, where we made a 3D model. We sent only the XYZ coordinates to the people who folded the glass or extruded the mullions in the same direction of the glass, and also separated the idea of vertical and horizontal mullions, in vertical being welded thin steel, hence holding the glass on a distance, and the glass itself not being a grid, but a set of bands. Very shortly after, we got interested in an idea of making a building that's actually a landmark building in Tribeca, of translucent stone, one of the first buildings that actually have translucent stone on the outside. Usually it's something like a beautiful alabaster skin on the inside. And hence this building glows, of course, by day on the inside, by night on the outside. And it kind of rethinks the idea of landmark. Normally in New York, you would kind of copy a landmark building, but looking at the landmark district, every building was different. So I proposed to this preservation committee, to look at proportional systems, material quality, and go from there. And then we took the rhythm of the two neighbors, intersected it over our building, and came up with a 3D pixelation for the facade. That we prototyped in Italy. The stone originally used in Tribeca comes from, funny enough, a quarry in Portugal. So we went to Portugal, got the same stone, and then worked with a facade consultant on getting this 3D pixelation in a way that also the facade was openable and varying at all times. This prototype was made in Italy. We had German mullions, the only ones who make thin steel reinforced mullions, called Schuko. Schuko is actually made in America in a very dumb system, so we could not fathom using that. And then a tower we're working on currently that's in design, so I'll show it very briefly, but is a tower that thinks of anomalies. And the idea of anomalies, which is also a chapter in the book, is working with the idea of, let's say, 80% standard, 20% non-standard of a building, especially when a building gets much larger, like this tower is 200 meters tall in Rotterdam. And the anomalies occur in the form of what we call sky lobbies that are also kind of green lungs for the tower. And they are completely differently fabricated, prefabricated, made more like pieces of furniture, and create complete other conditions within the tower. So these sky lobbies kind of wind around the tower on different elevations and different facades, and are connected with thin lines that connect the sky lobbies all the way up to the tower, which then at night you start to see these arteries connecting sky lobbies. In the sky lobbies are mostly public functions such as libraries, restaurants, and gyms for the building, but also for the city. So the idea is really to have the public areas on the ground floor, which is mostly retail and restaurants, pull up into the tower as kind of the city occupying the tower itself. We just won yesterday, that's why I'm putting it in, the design award for a very strange structure, which is probably one of the smaller projects we have done. But we actually like the idea of doing small projects to investigate things and to prototype things that we can then use hopefully later in larger projects. This is quite a funny one though. It's an 8-story townhouse for one family in Soho. And originally we started to notice that the original building number 1 was extended by number 2 that followed all the zoning codes and setback codes of the city. But they were kind of approximating the same size, and we realized it was time for number 3, which was kind of an extra large volume that is set back from the building in all directions through balconies, terraces, and roof terraces. So it's kind of creating external space around the building. But as it's made of movable slats and a steel frame, we kind of, for the DOB, called it a sunscreen, and sunscreens don't have DOB restrictions. So we made that a lot larger than the building was actually allowed to be, as it was just a sunscreen. And I think the city did not quite understand that concept and let us get away with it. So as you can see here, this trellis is also used for green gardens on the top that then can grow plants down and is openable. So that we really can play around with climate conditions. What we felt was very important was that the trellis would transform. We call it the climate skin really, but the climate skin would transform as the panels open. So if the system is closed, the panels are in line, and if it opens, it feathers out like a bird wing. And of course, we had to prototype that because it was a little tricky, especially with fingers in the neighborhood. It was quite an excessive movement and a very large feathering. Sorry for the sound. I theoretically could stop this. But anyway, here these were prototyping to do it automatically. So we have actuators on site and the contractor is testing the movement of this thing. And then here you can see the difference between the open and closed. And what is quite fun is that in summer, when you close it, you of course get natural shading and ventilation between the screen and the building. In winter, if you open it, you get passive solar radiation. And we actually calculated with a plugin that we could reduce, the Honeybee Rhino plugin, that we could reduce energy use of the building overall 45%. So that's an annual saving of 45%. So that was quite interesting. And you get these weird transformations. The ground floor building is an old industrial building, a tiny industrial building. So we just cleaned it up. We took paint of everything. So you have the rough beams and the rough walls. And then here you can see the difference. Now you're looking out over Soho, and here in the summer it would be closed. So you get this really interesting zone between the two skins. And then in the back, of course, you get this interesting condition that you have an 8-story black stair moving up and a glass elevator. The glass elevator is lit by a slot that we cut all the way 8 stories through the building, and south light comes in. A lot of vertical slots in the building to just give it continuity. It's very small floor plates, so it was kind of interesting that each floor has its own kind of living circumstance, and then they're connected by stairs. And then here I'm standing on the top of the building where you start to see these vertical slots, and also the way you can occupy the space between the building and the trellis. So you can see also the transformation here happening. I'll get into think shapes. So think shapes for us are, every project is considered an object in the sense that we feel has to be 3D designed. We often work in a way that is probably closer to industrial design, in the sense that rather than making smaller presentation or representation models, we are interested in making one-to-one prototypes, as you might have noticed. We do that because we feel it's very interesting to see whether we can use those prototypes. Architecture being often the one-to-one prototype that is then built and that's it. Car design, they make $1 million prototypes because they're making a lot of cars, so they can spread out this investment. We have the problem in architecture that we don't have that luxury of repeating endlessly what we innovate. So the innovation really has to come from one-to-one mock-ups and prototypes, and then immediately also building it. So you go through this innovation process really fast. But what we hope is that it gives individuality character, that prefabrication will make for clean and wasteless production and faster production time. And then obviously architecture can also be branding. So Theo just mentioned this. We won a competition for the Asian Games 2022 in May 2018 with landscape architects called Melk here in New York, Dutch office, but located also in New York, same building actually as we are. Thornton Tomasetti, structure engineers. MIC is mobility in chain, Italian traffic and mobility and infrastructural engineers. And we decided to change something. Typically, as you might know, architects have sub-engineers and landscape people under them. And we felt that, Jean Nouvel once mentioned in a lecture in Columbia that he did 45 competitions before he won one. Some people are much faster in that, as Patrick knows, who I see on the little screen here. But yeah, some of us are not. And so I thought, I was approximating that probably also pretty quickly, and thought if you can't do it in the way you always do it, maybe we should drastically change the model. And so I proposed to my business partner here to go in as equal partners with Melk and Thornton Tomasetti. So equal partners with the structure engineer and the landscape architect. Also, because you might know, any competition where it's an invited competition, 5 offices, you get about 6 weeks to do 116-acre sites and 7 buildings. So that's not a small challenge. Here you see the whole park. It's 1.6 kilometers long, 47 hectares, and we built about 186,000 square meters. So it's quite a bit of building. You might wonder, why don't you see that? So I'll explain that to you. One thing I thought was exciting, this is built in Hangzhou, just under Shanghai, is that the site itself was already some sort of green area. So we weren't destroying some precious little village and telling farmers to live in skyscrapers, which I always find a little daunting in China. But we were really asked to make this park a sponge city or a green lung for the city. The government in China understands that by hardening all the surfaces of the cities, we get a drastic problem with water. One, you diminish the amount of soil that can be absorbing the water, but by doing that, you also make the surface harder. And hence, when it rains, you actually now have flooding. So we've all seen this, right? Where suddenly we have all these cities that are flooding, and that comes really because we don't have enough surface to absorb the water. The other reason why we won, I think, is because we decided not to follow the rules of the competition. And that was on the bottom left, where the park is divided by a road and a river. And they were proposing to put the stadiums right in the middle here next to each other, which we found was kind of a strange idea, because the parks would be the backyard of the stadiums, and you're putting a massive amount of pressure, just traffic wise and pedestrian wise on a very small area. So we decided to change the idea, and that's the one circled in or squared, I should say, on the right bottom, to say each stadium, one is a field hockey stadium, open air, and one is a hybrid building for sports and concerts, to put them in the middle of each section, to kind of see them as generators of new activities and new circumstances in those pieces of park. And then to translate the idea that the competition was asking for, which was an underground shopping mall, into something we call the Green Valley. So this is, or the Valley Village, we called it a Valley Village, to go under the road, under the river, and connect these two stadiums or two hybrid buildings in one fluid sweep. We knew as a team, we had this discussion that breaking the rules of a competition can mean two things. One, you get disqualified. Two, you win. And there's not much gray area in between that. So we took that decision as a team, and we're fully aware of the risk that this might be a problem. So here you see a little bit of the data. So the hockey stadium is about 14,000 square meters, has a span of 125-meter wing for shading above it in one big gigantic sweep. There's a 530-meter long shopping mall with green roofs, solar shading, and escalators to the road. And of course, the river had to become an aqueduct. And then there is the hybrid building for table tennis and concerts. Now, we looked immediately at the idea of other users. So we started to look at potential activities for the park in sports, cultural, food, nature, entertainment, and connectivity. And we're very focused on making this idea of the sponge city work. So the idea was to have bioswales to filter and the water and retain stormwater, to create wetlands. Same idea. Originally, the site had wetlands, but they were completely basically destroyed and built over. So we decided to bring quite a bit of it back, introduce local vegetation, restore the local biome, and introduce perforated pavement where we had to make paths. Wetlands are not just functional, they're also extremely beautiful. Here you see the bamboo tea houses we introduced. And here you are in the tea house looking over the lake. It's a very large wetland. And of course, we made things for the use after the games, such as playgrounds, skateboarding, and things like that. So here you start to see what was quite strange and fun, maybe, is that the competition in 2018 was actually a competition that was after an initial competition that was done in China itself. The results were not what the competition committee wanted, and then made it an international invited competition where we were invited. But that also meant the time was seriously constrained. So while we were announced as winner, our drawings were already taken and they started the landscape right there and then. So we won, let's say, half of May. By half of June, they were digging for our mall and to create the viaduct. So what is very strange, you can see here, is that we're actually nearing completion very fast, a year ahead of schedule. But I'll go a little bit through the programs first. So the Valley Village, as you can see here, has essentially, as I said, 530-meter long spread, pedestrian bridges going over the road and river, the Valley Village itself going under, small pavilions with green roofs and glass in the green park as it dips down. And also on the sides, of course, there are long stretches of retail and restaurants that are also having parking garages, underground parking garages behind it, all of it with natural ventilation and natural daylighting. What was great about the fact that we were trying to have this sustainable fact is one of the efforts they're asking you is a zero earth strategy. And that sounds very futuristic, but it's a very basic one where you basically promise to keep the earth that you excavate for the wetlands, the Valley Village Mall, and other underground things, that you keep it on site, which was actually quite amazing because it started to happen that the buildings, the two buildings you see, are really tucked into a very hilly landscape, and hills go up as high as 17, 18 meters, which also creates an incredible silence in the middle of the park. So on a sensory level, it's really nice to have these very high hills. So here you see that principle. You also see how the Valley Village has these underground parkings connect to it, behind it, the earth on top of the parking, and these wind catchers that also have solar panels. So these long awnings that are providing shading and wind down in the Valley Village also have solar panels, so natural lighting is always on, obviously also for safety. So here you are on the middle road and you're looking down to the field hockey stadium. You see the solar wings and the valleys. And here you see how it's now built. So it's actually really uncanny how similar it is and how incredibly precise they followed our drawings. Interesting, of course, is by huge pressure, they also have no time to deviate. So we gave all the construction details, all the drawings straight to the contractor, probably a little bit behind the back of the client because they were asking us for details. I'll explain a little bit later. This had something to do with COVID. And then here it's really beautiful, but you start to see how that light that is caught by the solar panels already starts to light the valley village as it is still under construction. You see this, the shops are still empty. They're supposed to be filled, I think, by the end of May, as the games are in September. One of the stadiums, as I said, is a field hockey stadium. It's a kind of a seed of life diagram. The seed of life is basically a sort of a sacred geometry that is following patterns in nature that are viewed from a mathematical viewpoint with broad implications. Patterns have also their corresponding symbolism that are interesting from an overall mathematical logic. The two spheres or ellipses represented here, one of the field and one of the wing, are basically following a symbol called Vesica Pisces. It's used for many other reasons as well. People who know a little bit of history know a lot more about that. But yeah, we thought it was interesting. That was kind of this hidden meaning that you saw only from the air. But what was also the other reason is we wanted the field to be part of the building. So by recessing the site on the stadium side 5 meters, but on the end of the field being 0, so the site around it is tapering, it made it part as a park topology rather than as just a sport field. And also the wing here, the 125 meters span, is covering these seats, which are about 5,000 seats. So as you can see, the building itself creates itself by curving the arena slightly. The 5,000 seats behind it starts to occur another building that is the lobby building. That is a glass double curved facade. You see the dip in the landscape, the wing coming over it. Now this wing is so lightweight that we needed to tie them down with concrete abutments that you see holding the wings here. Otherwise the whole thing would fly up. And essentially the wingspan are 2 big trusses that fly basically from one to the other and are completely free of the building. So this wing never touches the building. And of course there is again a hidden building next to it, an underground building, and that is the exhibition center that has a green roof and has glass facades, but really tapers down to the ground. Now, the way we worked through COVID, and I think it was really interesting, I think we actually got a better grip on the whole process, was through our 3D Rhino model went straight to the contractor who made it into a 3D BIM model. And then from then on, we worked with them on BIM to kind of figure out erection methods, optimization of steel systems, and ways of building everything faster. So through BIM, we actually managed to save overall 1,120 tons of steel. We shortened the construction time by 20%. And because I didn't want the structure to be so overwhelming, I asked them to tie it back with rods rather than steel profiles. And what was interesting is that the wing then had to have this massive ring around it that literally goes from a diameter of 1.5 meters to a diameter of 1 meter, which sounded like way too much. But as you can see here, if you put it on such a massive scale, it is actually quite in proportion. And I think the ring is quite beautiful. So here, the section through the building, the glass facade on the left, the seats on the right. As you can see, the building also dips in the ground to get to that lower area of the field so that the field starts 5 meters down. And then here you start to see the entrance as it nearing completion. We also felt that the site had to move up to the entrance. So hence these small landscape areas moving up. And then this is the back view where you see the field as it's 5 meter dipped at the seats, which also makes the building sit really in the landscape rather than on the landscape. So the first whole section of seats is actually underground, you could say. And then how this is turning out in reality. As you can see, they're flying through the construction in incredible fast ways. And here you see how the Valley Village is starting to grow. The plants, as you can see, the green roofs are still kind of coming. We already went through a full cherry blossom season, which was a shocker because we went from a complete mud flat with buildings to grass and cherry blossom. I'll show you that photo in a minute. It's kind of very strange. But what you can see here also is how easily the site is connected, where the viaduct can be crossed over by pedestrian bridges, but there's also escalators going up to the middle road. So it's always trying to tie back feedback loops in and out of the site and in and out of the city. And then every road in the city is also connected back in the park. So the park is completely porous and accessible for the neighborhood. This is a really interesting stadium. I think it's because it's complete hybrid with a concert hall. We did not want the building to be sort of a white elephant after the games. So we looked at an interesting way to kind of get the complexity of the building. We kind of found a mysterious object called the chong, and the chong is found in graves. It's a jade element, an intersection of a cylinder with a square. And essentially, we started thinking of the intersection and possible intersection and shift as a way to start to understand the building as a much more complex entity, which then again is an alter ego underground as a very large fitness center, and they are also connected underground. The fitness center again with, of course, the green roofs, the skylights to give natural light and ventilation below, and the stadium with all its complexities. So by intersecting these two volumes, there are two skins that are the direct resultant of it. One is a glass diagrid, one is a kind of a copper clad skin. And here what you see, the roof essentially is what's something called a suspendome, which means the roof sits on the inner bowl, cantilevers out over the rest of the facade, and basically carries the facades directly from the roof, rendering the building completely column free. So all that complexity inside with, you'll see in a minute, with ramps and stairs, really allows for a set of multiple uses and double spaces, while also having no impact on the structure of the building. We went as far as making a hybrid out with seating. So we studied the Olympic arena, the requirements for those, which are extremely strict, the idea of a theater and how we could make a hybrid out of the seating to kind of make something where it could be used on both ways. And then here you start to see that the roof in the middle also has a skylight with a deflector. So also natural daylight comes into the stadium. And in the back, through the intersection on the left-hand side, through the shift is a VIP balcony that overlooks the wetlands. In the front, the shift created a really beautiful indent with a large awning that is the entrance. Here you have the brass shingle. So the BIM optimization, it was quite fun to play around with trying to get as least variations as possible. So we managed to reduce the shingles that are doubly curved and intersecting doubly curved because of the strange intersection model we had. There's only 85 variations for 5,000 shingles. So that really helped also the contractor making it affordable. And then the diagrid, we were interested in having this the largest possible diagrid. So the actual span is about 10 meters, the height is 5 meters. And we were interested in keeping the glass planar and create some sort of almost like eyelids for the glass, which you can see here. They're triangular fins that allows the glass to negotiate back to the curve, which means that if the light hits it, you get all these little silver slivers picking up the lights. So here you start to see the construction and how large it is, the tiny people. So here the glass is going on, and as you can see, it has this really very 3D effect because of the planar and the little eyelids. On the top here, on the top left, you start to see the eyelids more clearly. And of course, as it negotiates the curves, the eyelids also change direction. So it's quite an interesting parametric device. And the intersection also means that the brass in the front intersects the glass. So where you see the glass coming down and then meeting the ring of the brass shingles, then again the glass comes out at the bottom. So this highly complex intersection of these volumes created all kinds of interesting conditions. And the roof is negotiated by a ring of glass that is openable, and hence allows for passive ventilation. Inside, we developed the ceiling with a set of slats and embedded lights that really stress the rings of the suspendome. You see the deflector of the natural daylight hanging below it. And then here you see it as it works as an arena, but here how it can be transformed very easily as an event for concerts or theater. So we actually just had an event, I'll show you in a moment, but I just saw that on Instagram. They had an event for 2,500 teachers and students in the hall, where actually they already did this. So they're far ahead of my schedule, let's say. But they already were partying in it over the new year. So I'm really happy that that is a possibility. And then here you see actually our render and how similar it is to exactly what you just saw, where this negotiation of the rings of copper and of the diagrids start to play into it. Then one day, here we had these endless meetings with the engineers in China. On the left, you see the team of the local architects, the UAD group in Hangzhou. It's a research group at the university that helped us construct or communicate mostly actually with the clients. And then here I'm trying to explain to the engineers why a suspendome is a good idea. But then after that meeting, we drove to the restaurant, and I'm sitting in the back of the car, and I'm like looking at this image, thinking that looks very familiar. Am I already, are we already copied? I was like, no, this is actually your construction site. They just started building the landscape. So we are still negotiating the structure. They have started the landscape. Very scary idea. So yeah, and then shortly after, this has been the fastest process ever. I don't remember 2018, to be honest. We all canceled our vacations and just started drawing and kept drawing until I think February 2019. But then February 2019, as you can see, they also basically already started the foundations from our very first SD drawings, and literally going on site, driving from building to building, 1.6 kilometers, not that easy to quickly walk. So, and all buildings started at the same time with about 300 to 400 people on site daily. And then the way we managed, which I think actually saved us, because these buildings are enormous in scale. What saved us is that we got to know the BIM guy of the contractor. It's the guy who was laughing in the middle. He declared his love for the project to us and sent us an email. And we were like, oh, what are you doing? Can we see the drawings? Can we help you with something? And from then on, worked with him on the detailing in BIM. So here you can see the drawings are extremely similar. The weird intersection, the strange bulging we wanted, all happened exactly as we had in our Rhino model. And I have to say, it is really thanks to this genius here that was just in love with the project. So yeah, sometimes you have to, love comes into architecture at some points in different ways than we usually think of. So yeah, here you start to see this endless study also of the skylight and how the deflector works. The little eyelids of the planar glass. It really helped because of the planar glass, we could also make a double glazing. So the facade is actually super insulated. It has solar glass in it that deflects the light. When the sun is high, it deflects the light completely. In the winter, when it's lower, it allows some light in. So it can actually work for passive solar also. And then this is, of course, what we then get from the BIM guy, how he was very proud of being able, rather than one big crane, his theory was to build tiny little cranes everywhere, which then reduced the construction time by about 20% and the cost also quite enormously. Now, this is phenomenal. If you look at the tiny people that are sitting on the knots there, how big this roof is. But also he managed, and I have to say, this is really that BIM guy. He managed to install that whole roof in just 15 pieces, which was phenomenal. It really sped up the construction really fast. And here you see the enormous amounts of tiny cranes holding the suspendome and how incredibly thin that suspendome is. So yeah, the 1130 tons of steel saving was definitely here, also in the wing. And the other thing is, by the standardization of the curtain wall, he also saved $1.2 million in cost. The saving of the steel was $2 million in cost. So it's really interesting to see these numbers flying by. This photo I just put in because I thought it was so beautiful to see it at night and how the skin starts to shimmer in the lights, and the intersection being very, very clear and alien looking, especially in this one. This was one of the photos I got sent by the contractor. We were able also to keep track of the construction because our own team sent drones around on a bi-weekly basis, and I could literally go with the architect of record and hang with the drone in front of a facade. If you imagine that that these entry doors is about 6 meters high, you can imagine how high the building is. And if you would want to do site supervision in this building and you would like to see a detail on the top of the curtain wall, would not be possible. But it was strangely easy with the drones and the understanding of the 3Dness and the being able to ask the Menge, our guy in China, to just hang still for a second in the detail, and then being able to take some photos and send it to the contractor and said, hey, that rubber up there, if you tuck that in a little deeper, that will be much more beautiful. So it was an incredible thing. Very daring people working here. And then here, the way the building is, as you can see, it's very close. There are some little cranes left. You see also in the foreground the fitness center, as it is covered by this green roof. All these buildings do have small slivers of facade for natural daylighting and, of course, entrance and ventilation. It's been quite interesting to be able to make 7 sustainable buildings in a completely sustainable park, while still getting this formal complexity and this absolutely seamless collaboration. I have to say, after all the horror stories and having had myself some horror stories in working in China, this has been the most incredible experience where it's been quite seamless. Do you see the shift that I talked about as we were intersecting it? We also shifted the volumes, thus creating that VIP balcony in the back, which you see on the left there. And then this is inside the building. We literally have this render from ourselves. So it's really weird how absolutely similar the building has become. You see one of the ramps coming down. So the VIP area has a lobby, which is the future kind of concert hall, theater, cafe, that has ramps flying down along the inner bowl back to the entrance lobby, and then has also entrances into the bowl from there. And then here you start to see the whole park. All these tiny little glass things on the grass are all the skylights that are openable. And you see the wetlands as it's surrounding the areas, the hilliness. And then this was what I was saying about at some point, the cherry blossom and the flowers were suddenly in the equation. Supposedly, this is the moment where people like to take selfies. We keep getting photos from people online with themselves and the building. And then at night, you start to see much clearer the intersections and the way these volumes start to rotate around this thing. That's completely non-centric, the building. So there is no central entrance. Everything is flying around and everything is acentric. So we're calling it a set of wobbly discs that are kind of balancing and kind of holding this space in tension, allowing for a much more open use, a much more accessible space, and also a higher complexity in the ways it can be used and can be circulated around. And then this was the party. So I don't know how they got that light on top of the building, but this was the party with the 2,500 teachers and students in the building, and somehow they managed to make this strange star thing on the roof that normally is never there. And as you can see, the lighting of the park is slowly being installed as well. So yeah, it's 47 hectares, so it's a very large green area. And the reason why all these buildings are on the ground, by the way, is because the stipulation was it had to be 85% park. So the 15% is really the two stadiums and the partial pavilions of the Valley Village Mall that you saw. And all the other buildings are finding themselves underground with a whopping 2 meters of soil, because for a tree, you actually do need 2 meters of soil. So quite heavy concrete constructions, but very lightweight steel structures. So yeah, and all this and more you can see in the book that Theo just mentioned. Manuel de Landa was so kind to write a really great text for it. And there are many much stranger objects and solids in there with the 3 chapters. And thank you for listening to this. And if there's any questions, I'm happy to answer this, of course.
Sorry, I have a bit of a schizophrenic personality. My remote self is still on Zoom on my laptop, and I went old school. I went back to the lectern. So my question, Winka, is more, I mean, thank you for the talk. I mean, it was quite fantastic. But I think the things that are particularly striking to me is, especially in this kind of last couple of years, that a lot of this work has happened primarily, I think, with very different kind of workflows and with a kind of accelerated pace, which I think in some sense delivered on some of the promises of a lot of the kind of research that a lot of us have been working on to deliver the project actually quite early. And so I just wanted to speak to maybe some of the conversations we've had here today, and I think it's an ongoing conversation within the program and the AA, on the role of prototyping and research. I know the book speaks to it in some degree from both a practitioner's point of view, but also from a theoretical point of view. But this kind of applied practice, I think, is quite manifested in particular with the Asian Games project that has basically worked on at the scale of the detail to the scale of a kind of master plan. And I just thought maybe if you could give a kind of window into, I know this has been an ongoing preparatory way of exploring your work, but the scales and the coinciding of that, I think, is a quite unique opportunity maybe to gain some insight for the students, because you've had a long-standing relationship with research within an academic environment. I think in some sense that kind of synergy between the two would be interesting to kind of speak to, because I think it's something that's very important relative to how we also think about education. I mean, we speak to the fact that we try to move beyond kind of representational models and really try to think more systemically and prototypically, but then sometimes that falls into conversations that are at times rhetorical in terms of the larger arenas of how people interpret that. So I just thought, because of this experience, especially over the last 2 years with the development, it would be great to gain a little bit of an insight of the steps of your office, but also as an educator and an administrator, how that sort of factored into that.
Yeah, no, that's a very interesting question. Thank you, Theo. I think one thing I have always done in the office is circumventing the contractor. We have a big challenge here with contractors that really resist innovation. So my way around it, which I did very early on, as you know, with the folded glass building, is where the glass is actually literally folded in Spain. Is to work with manufacturers before I get to the contractor. So of course you need the contractor, but then, if I want to innovate a certain segment of the building, typically our office finds the people who can do it. We work with those people. We get a quote before we get to the contractor, so that the contractor has no reason, because here, otherwise, if I would do anything like that, they would just triple their square footage price, and the buildings would never get built. So by solving the problem before it gets to the contractor, I essentially say to them, well, this is difficult, but these are the quotes by two different companies or one company. If you have someone who can do it better for cheaper, go right ahead. But otherwise, we like to use these people. And that attitude is very close, of course, to industrial design, where you work with a manufacturer rather than a contractor. And that also has been helpful in the sense that then is very easily translated into prototyping, because now you are working with the manufacturer. In education, we have translated that also in the sense that for our graduating year, we have a set of external companies that work with us and that sponsor the student research and faculty research on a very large scale. Cemex is a concrete company that is studying currently how to reduce their carbon footprint. They have a R&D center in Switzerland that we've done workshops at, and they're often also at Penn. And the lab that I run is connected to our robotics lab that we started maybe 5 years ago. So that also then gets a good influx of materials. We do the same with a manufacturer of carbon fiber. We have collaborations also with, strangely enough, with developers or with cities. We worked with the city of Cairo and the government of Egypt to look at downtown Cairo. We're currently working with Istanbul. We've done a lot of work with developers of Colombia, Medellin, and Bogota, Cartagena. We're currently working with someone in Mexico City. So it's been interesting. And the idea is more like, almost like how maybe the MIT Media Lab does it, where clients come in and ask for innovations, and then we do the research, we do the design, we make a book for them, we publish the book, we also give them the book. But they sponsor the book, they sponsor the workshop, and they sponsor the trip. So it's kind of an interesting intertwined collaboration that has given enormous benefits, I think, for the students and the faculty to kind of have a continuous possibility for funded research. Although, we have obviously people who get much bigger funded research in the form of $3 or $5 million, but this is on a much smaller scale, a much more direct scale, and a very student included level. So it's been super fun, and I think it's helped. Actually, I often know the people through the office, so I push them into the university, but it's also sometimes vice versa. So it's a nice way of working, and it's really changed the school drastically, I think.
Okay, thank you so much, Winka. Is there any final questions for Winka, either on the chat or for the people that are here with me?
I see some.
Any?
Thank you, Yael. There is someone who's asking for tips for architecture students, keeping in mind how the world is changing ecologically and technically. Yeah, I mean, that's an interesting question, right? Like, I think what I tell our students is you have to be just as multi-platform as you can. The beauty of digital design is not to focus on one software. The beauty is to be super fluid and be able to move from platform to platform very quickly. I think 20 years, what is it, more than 20 years at this point, of digital design has become like we're sketching in the computer, we're testing things in the computer. It's become very playful, I think. And I often look at our students and I think how much fun to be a student. But I also understand that for you guys, it's a challenge. You look at the outside world and you think, what am I going to do? And I think, the best thing you can do is to do research in the most rigorous possible way, to understand what you're talking about, to have an argument, and to communicate the argument, as much as you can. Architects typically have been too much in an ivory tower, and I think the beauty now is that we're coming out and we're talking to people and we're communicating our ideas. And at Penn, we publish a book called Pressing Matters every year. And I realized after a few years that actually that book was used as teaching material in other schools in the US. So I asked the publisher to publish it. And we very, very openly share design methodologies, the way we teach. We tend to teach much more integral. We don't have courses somewhere and studios somewhere. We integrate technical knowledge with studio or theoretical knowledge with studio. So this kind of way of teaching, we talk about openly in our books. So they're also free online as ebooks. So you can just go to our website for Penn and download them or read through them. But, I think the idea of open source is really important. The idea that you understand that architecture operates on multiple platforms and that, software also operates on multiple platforms is really the way to go, I think, and have fun with it. Every time you study, when I studied, there was no work. And that's why I thought, well, let me do a postgraduate. And I came to New York and there was no work. All the teachers were like complaining and crying and there was no work. Well, finally you come out of school and you work, right? I mean, in the end, it's just, there's always work somewhere, let's put it that way. And it's actually quite interesting that our agency as an architect, I think, has drastically increased with the fact that society and climates have become so much more complex. So you can find your voice, I think, in all of it. And then I think the most important, what I said with the stadium, is also not suppress the design, right? Like design is also our agency. So I think it's really important to understand that design is a big part of the solution also. So in that sense, mission is set. Alan said something, hold on one second. Facing in Camden, yeah. Yeah. So Ellen is asking the problems we face in a city, right? Like New York or London, when we build something with community boards and zoning and codes and things like that. And he's asking what the planning was in the Asian Games and whether we had that. Ellen is really interesting because the Asian Games is not the regional government, it's the government. It's Olympics for them. Essentially, it's the Asian Olympics. So we worked only with the top government level. And I have to say, they couldn't have been more visionary and understanding. And I mean, no process is flawless, don't get me wrong. We've definitely had hurdles and have spent like 4 or 5 hours trying to convince someone of one roof system. It's not easy, but I think what was really amazing there is that because the buildings are in the site, we had no zoning restrictions except for one, which was originally the fitness center next to the table tennis stadium was originally in the table tennis stadium. So all these functions were in the building. So when we did the competition, we had a massive amount of program in that building. And then it turned out that there was something about you could only be a 1 or 2 story building or something. And otherwise some other zoning things would go in effect. So actually it was quite beautiful. The building itself is like a gigantic sculpture now inside. The ground floor has a ton of program. The ground floor has all kinds of things for the players, fitting rooms, massage rooms, offices for officials, press offices. The whole Olympic thing is on the ground floor next to the stadium, but then in the back, let's say. But then all the other programs went into the fitness center underground next to it. And that was really nice for the building, but it was actually a zoning restriction that we had to comply with. But I think for the building, ultimately, it was, it just became this gigantic sculpture with just these beautiful flying ramps and this VIP terrace in the back. It actually made the building much better. So, that was initially very scary to hear the news because we didn't know the solution. But with the help of the local architect and the local architect also of the client, we figured out that could be solved by the building next to it. So, but yeah, I mean, 2018 till about 3 months ago have been absolutely hectic. So, so a big project like that, we have a relatively small office. It's quite intense for the office, but it's also one of the most amazing things. And the fact that we had a lucky coincidence of working with this BIM person who's very young and in charge of the whole thing. It was amazing. So that really helped us develop it so much quicker. I don't know how we would have done it otherwise, to be honest. But he found us.
Okay, I think that's a great way to kind of segue into our immediate thank yous, Winka, virtually, and next time that you're coming through London, we can actually kind of celebrate not only this talk, but also you working in London as well. So I just want to thank you on behalf of everybody at the AA and the DRL, and invite any guests who are interested to follow the reviews tomorrow. We're going to pick up for day 2 at noon. And I just want to say everybody to stay safe and really to be quite spirited in the conversations and the discussions around architecture. It's kind of what brings us all together and makes occasions like this, I think, not only very important for us, but I think it sort of creates a kind of model for a lot of the students to see possibilities of setting up their own thing, doing their own thing, and feeling as part of a community, not as students basically within an institution, but collaborators in a very kind of expansive field and territory that architecture emerges in as we sort of awake from the pandemic. So thank you so much, Winka, and thank you everybody who joined for the lecture, and we look forward to seeing everybody soon. Thanks.
Thank you, Theo, and good luck everyone tomorrow.
Thanks. Bye. Bye-bye.
Bye. Great to see you all. Bye.
Bye-bye.